Good afternoon and welcome everyone. Welcome to panel 4, our last session, session 4, where we'll be examining national and global government policies and programs. I'm thrilled to be moderating this all-woman panel, and I'm excited to hear their presentation. As usual, we will have to go over some housekeeping items, but I'm sure you've been hearing that every session, so I'll keep it short. First, I'd like to thank our sponsors, especially DTE, for making this event possible. Please use the chat box to ask questions of the speakers after their presentation. We will have the last 15 minutes of today for the speakers to be answering some of the questions. If there are any unanswered or remaining questions, we will give it back to the speakers for them to answer it after the conference. And finally, please join us at the end of the day networking, where we can actually meet informally and have some discussions about topics that you may have missed. So on to the program, we have our first presenter is Dinah Shi, who will speak to us about the assessment for a federal buy clean policy for carbon-intensive construction materials in the U.S. A little about Dinah. She's a consultant at Global Efficiency Intelligence, studying green procurement policy. Recent research topics include international GPP, embodied carbon in industrial materials, and the political economy of coal in China. She's pursuing a master's of Chinese economic and political affairs at UC San Diego with a specialization in Chinese environment. Previously, she worked as a software engineer in private industry. We can bring on Dina. The floor is yours, Dina.
Hello. I think you have my screen sharing set up. All right, thank you so much for the introduction. My name is Dinah, and today I'm going to be speaking about federal buy clean policy for construction materials in the United States in particular. This study was conducted by Global Efficiency Intelligence and made possible with support from the Third Way. GEI is an energy, environmental consulting, and market research firm led by Dr. Ali Hassan-Beji, who is also the lead author on this study. So to set the stage, in 2018, the United States spent $110 billion in federal non-defense infrastructure, including highways and bridges, and 55% of greenhouse gas emissions attributed to public institutions in the US are a result of purchased goods and services. So public entities have large-scale purchasing power. And when those public entities leverage that large-scale purchasing power towards buying goods and services with a lower carbon footprint, they can help drive markets in the direction of sustainability. This is where green public procurement, or GPP, comes in. GPP is a policy instrument to leverage public spending to achieve green goals like the reduction of emissions or just general reduction on environmental impacts. In March of this year, the Clean Future Act was introduced, and it is a comprehensive bill that proposes
Dinah,
both sector-specific and economy-wide. Yes.
Your voice is coming in a little staticky. Would you mind It's a little bit low quality.
Would I mind repeating? Is that what you said?
It's coming in as static. So would you mind refreshing your window just to see if that solves the audio?
Sorry, folks.
Sorry, everyone. This is part of being virtual. Everything worked before, but once we go live, it's hard to figure out what's going on. So let's try this again. Dinah, can you speak?
Is this any better?
Much better, much better.
Oh, shocking. Okay. What part should I start at?
Yeah, go for it. Start from the beginning.
That this is okay. Oh, okay. All right, yeah. Sure. Well, I was going to say, since this is the introductory slide anyways, you're not necessarily missing out on too much. So the two first bullet points are basically setting the stage for how public entities have this large-scale purchasing power. And when those public entities leverage that large-scale purchasing power towards buying goods and services with a lower carbon footprint, they can help drive markets in the direction of sustainability. This is kind of the whole point of this is where green public procurement comes in. Green public procurement, or GPP, is a policy instrument to leverage that public spending to achieve green goals, such as the reduction of greenhouse gas emissions. In March of this year, the Clean Future Act was introduced, and it's a comprehensive bill that proposes both sector-specific and economy-wide policies to achieve net zero greenhouse gas emissions in the United States by 2050. And there's an entire section on the industrial section, with a lot of mention of the creation of a federal Buy Clean program. So that's what this study is trying to look at. We did a couple of things. The first thing we did was estimate the scale of public procurement of construction, cement, and steel. Then using that scale, we estimated the associated carbon or CO2 emissions using CO2 intensities. We developed a number of Buy Clean target scenarios, so what the federal Buy Clean program could potentially look at or aim to do. And then we computed emissions reductions for each of those scenarios to look at the potential reductions for each of those targets. We then reviewed proposed policies as well as international best practice in GPP today. We actually evaluated scale of public procurement at both the federal and state levels, as well as the emissions reduction potential at federal and state levels. But in the interest of time, I won't be sharing the state level findings in this presentation today. I'm going to be focusing on the federal level findings. But we do plan to publish the full report, including the state level results, sometime in mid-August. All right, so getting started, the scale of public procurement of cement. In 2018, the US produced 86 megatons of cement, and total consumption in the US was 98.5 megatons. 46% of that went towards public construction, and we estimate around 25% of the public construction was through federal funds, with the rest being through state and local government funds. So we computed a weighted average CO2 intensity for cement produced in the US, as well as net imported cement, to calculate annual CO2 emissions from cement consumption. And that's what we see in this figure on the right, figure 1, where the blue is CO2 emissions associated with federally procured cement used towards public construction. The orange is state and local, and then the gray bar is non-public. So we can see that around 36 megatons of CO2 was associated or is associated with public construction in 2018. Using that same process for steel, the US produced 87 megatons of crude steel in 2018, 33% of which was produced using BF-BOF, or blast furnace basic oxygen furnace production, and 67% using EAF, or electric arc furnace. Total consumption was 101 megatons, 43% of which went towards construction and 18 towards public construction. And fairly similar to cement, 27% was through federal funds, with the rest being through state and local funds. So again, we computed a weighted average CO2 intensity for steel produced in the US, as well as net imported steel, to compute the annual CO2 emissions from steel consumption, which again is plotted on the right in figure 2. Note that steel is used in a wide variety of applications, such as vehicles and appliances, and not just in construction. So the yellow bar is showing steel consumption in other market segments that are not construction. So we see that that makes up a significant portion of total steel consumption, and as a result, total CO2 emissions associated with steel consumption. For public construction, we computed around 21 megatons of CO2 associated with federally or state public procurement. So using those numbers, we can then try to get an idea of what the impact of Buy Clean policy might be. We developed a number of target reduction targets, and these are industry level targets, not necessarily for specific products, whereas we would expect the actual implementation detail of Buy Clean to set product specific intensity targets. So in the baseline case for cement, we can see the CO2 intensity is about 806 kilograms of CO2 per ton of cement. And if we look at something like a low target scenario with a 10% reduction in CO2 intensity, that number becomes 725. Some of the activities that could potentially result in that emissions reduction are things like energy efficiency, fuel switching, and the use of SCMs, or supplementary cementitious materials, instead of clinker. However, in the case of cement, deep decarbonization, cannot be achieved by energy efficiency alone due to process emissions. So in the production of cement, process-related CO2 emissions from calcination account for over half of total emissions, which is why when we look at the high and transformative targets at the 30 to 50% reduction in CO2 intensity, those are definitely going to require a lot of the activities I just mentioned, such as energy efficiency and fuel switching, but they're also likely going to require carbon capture and sequestration. So we plotted the emissions reductions for each of those scenarios on this graph here, where blue is again associated with federal funds, orange is state and local funds. And in this graph, the striped line is potential indirect impact. And potential indirect impact assumes that the changes made to plants in order for the cement produced to meet the Buy Clean standards for public construction, that those changes also impact the CO2 intensity of all cement produced for non-public or non-government projects as well. In the low target scenario with a 10% reduction in carbon intensity, we see about 3.6 megatons of CO2 emissions reduced annually. And in the transformative scenario, that becomes 18. If we include the potential indirect impacts, it's over double what the two numbers that I just said are. So clearly there's a lot of potential. A similar process for steel, we looked at what the baseline is. Currently, it's about 1,100 kilograms of CO2 per ton of steel produced. And again, that's the weighted average for both domestic and imported steel. What's interesting in the case of steel is that America-made steel already is very carbon competitive, which is to say that US steel has lower carbon intensity than most imported steel. And that's because of what I was saying earlier, around 67% of steel produced in the US uses electric arc furnace, or EAF. And that's actually one of the pathways that a lot of countries look to when they're trying to reduce the carbon intensity of the steel that they produce. So the US is already doing pretty good on this front. And that means that Buy Clean will immediately reward US steelmakers because US steel does have lower embodied emissions. So in the starter and low target scenarios, the US already meets this threshold, but of course there's room for improvement. So in the medium, high, and transformative scenarios, some of the potential activities that could lead to that level of reduction include energy efficiency, fuel switching, electrification, so even more production using EAF, carbon capture and sequestration, and transformative technologies such as green hydrogen. Again, we plotted the emissions reductions for each of those scenarios. In the low scenario, we see 2 megatons per year reduced in CO2 emissions. In the transformative scenario, about 10 megatons of CO2 emissions reduction for public construction. If we assume the same potential indirect impacts, which is to say that steel produced for all construction, not for public and non-public construction, then the potential emissions reductions more than doubles. And because steel is used in so many applications outside of construction as well, if we assume that the reduced CO2 intensity has positive spillover effects into steel production for non-construction steel, then the potential emissions reduction is even higher. And that's not plotted on this graph, but we estimate that to be over 5-fold what we're looking at with just public construction. So just the blue and orange bars here. So our analysis tells us that there is a lot of potential for emissions reductions as a result of Buy Clean, or green public procurement policy. We then looked at current and proposed Buy Clean policies. And I should have mentioned this earlier, but Buy Clean is what green public procurement is typically referred to, or is commonly known as in the United States. So earlier this year, the Clean Future Act had a section on the industrial sector, and a lot of points were very relevant to this particular audience and this particular presentation. So one of the things it proposed was increased transparency of embodied emissions in eligible materials by creating a product category rule for each product that is primarily composed of one of these materials. It also proposes to establish a database for environmental product declarations. And the eligible materials list to start is aluminum, iron, steel, concrete, and cement. It also proposes to establish a federal Buy Clean program, and that also means establishing Buy Clean standards for federally funded infrastructure projects. It also named the creation of a Climate Star program modeled after the Energy Star program to identify and promote products with lower embodied emissions. But it's not just at the federal level where Buy Clean policy or green public procurement is gaining a lot of interest. It's also happening at the state level. California was the first mover in the US, passing the Buy Clean California Act in 2017. And actually, just as of 2 weeks ago, as of July 1st, California now requires awarding authorities to verify global warming potential compliance for eligible materials. 7 other states have either just recently passed policy to do with the reduction of embodied carbon in public procurement or are in the process of moving some of these policies through legislature. We also looked at international best practice in the context of what learnings could be applied in the creation of a federal Buy Clean program for the United States. I'm not going to focus too much on this because I know that Cecilia will be speaking to this in a couple of minutes in this panel, but I did want to highlight 3 countries in particular: the Netherlands, South Korea, and the European Union. The Netherlands is widely seen as one of the best, if not the best, implementations of GPP in the world right now for a number of reasons. One of which is that they look at project scale life cycle analysis. And this is really great because it project scale reductions in project scale tend to have much higher possible emissions reduction. And one of the drawbacks that can happen when we only set requirements on specific eligible materials is, for example, if a bidder is trying to lower the amount of embodied carbon in their project, they might choose to replace cement and steel with something that's not an eligible material or not covered in the list, such as wood. And that wood or another material, let's say, but that substitute material does not necessarily have lower embodied emissions, especially if we think about the fact that they might have different durability. So if they did substitute with wood, but that required more maintenance over time or more frequent replacement, then perhaps over the life cycle of the project, the embodied emissions are actually higher. So a project scale LCA is really good for kind of dealing with all of those implementation details. The Netherlands has also created a piece of software called DuboCalc, which makes that project scale LCA much more easy. And it produces an environmental indicator, which makes it easier to for procurement, for people who make procurement decisions to compare the environmental impact of competing bids. They also fully monetize emissions reductions. So instead of just requiring you to meet a minimum, every reduction beyond that is rewarded through a price reduction. South Korea has a fully digitized procurement system that handles everything from tendering to contracting to payments to monitoring. And that really streamlines the implementation of green procurement. And it also makes it a lot more feasible to monitor, to answer questions like what is the actual realized impact of Buy Clean or green public procurement on emissions reduction for public purchases. The European Commission has created a set of GPP criteria for its member states, but rather than creating one set of criteria, they've created 2. One called the core criteria, which is a little bit more feasible, and one called the comprehensive criteria, which has more ambitious reduction goals. And this is really great because while we do want a certain minimum requirement to eliminate bad actors, let's say, we don't want to shut out too many producers or manufacturers. But at the same time, we want to incentivize and reward the companies and producers who really do go above and beyond and invest in a lot of breakthrough innovation or breakthrough technology. And that's what that 2-tiered structure or 2-tiered system is really good at addressing. For more on how these kind of best practices might be applied in the US context, definitely take a look at the full report. So in conclusion, the scale of public procurement of construction materials in the United States is significant. And that means that Buy Clean policy or embodied carbon policy has the potential to lead to large emissions reductions and send strong market signals. When we consider the indirect impacts on non-public and non-construction market segments, the emissions reduction potential is even larger. Buy Clean would reward US steel producers right off the bat because US steel is already very carbon competitive. And of course, policy and implementation details are very important. So the implementation of the federal Buy Clean program should apply learnings from international best practice, and especially taking notes and taking cues from the Netherlands. And with that, I thank you for your attention, and I will turn it back to Sadiqa.
Thank you, Dinah, for that fantastic overview of various GPP programs and incentives around the world. And it's encouraging to know that the US Steel is competitive already. Didn't I tell you guys we hold the best for last? We've got more wonderful presentations coming up. Our next presenter is Sharon Metzger, who will be presenting on modernizing the US building stock through the Advanced Building Construction Initiatives. Little about Sharon. She is the residential program manager and lead team member at the Pacific Northwest National Laboratory, supporting the Residential Buildings Integration Program in the Building Technology Office at the U.S. Department of Energy. Sharon also uses her background in both lab testing, field validation, and project management to support the strategy development for the Advanced Building Construction Initiative. Sharon has a master's in mechanical engineering from the University of Washington. She's a professional engineer and is a project management professional. Without further ado, Sharon, it's your turn.
Thank you so much. Hi, everyone. All right, great. Looks like you can see the slides. So I just want to say it's great to be here today. So excited to see my fellow panelists' presentations as well, because it's very interconnected so far. Can't wait to see more as well. And I'll just start by saying that this initiative is led by Joan Glickman at the Department of Energy. There's a number of people involved in developing the work for this initiative, as well as strategizing to kind of come up with the global perspective that's going to be presented here today. So I'm just a member of the team presenting today, member of a much larger team. So thanks for having me. Let's see if this will, can you all, I think you can see that. All right. So let's just start by talking about kind of the big picture here. A number of people lately, including our current president, have talked about needing this carbon neutral building sector by 2050. And that is, it seems to be that all the experts are agreeing that this is something that we need to have in order to combat our climate change challenges. This is definitely possible, but it is not an easy feat to completely radically change not only the existing building stock, but address all of the needs coming down the line for new construction as well. And so in thinking about this and just the speed and scale at which that needs to happen, that's kind of where what we're going to talk about a little bit more today. Before we get into the Advanced Building Construction Initiative, as a way to address that, we'll just talk a little bit more about our building stock today. So right now, the U.S. building stock is about 125 million buildings. It uses about 40% of the total energy in the U.S. It's a large portion of our carbon emissions. It accounts for 75% of our peak demand, and 75% of our electricity is used on our building stock right now. And a number of our buildings are over, around 50% of our buildings are more than 40 years old. So we have a big challenge ahead of us. Additionally, right now, the way that our buildings are being built is not that dissimilar from how they have been built for a long time. You can see that by these pictures on the slides here, that the Empire State Building was built with a similar building practice that was used by even some of the latest buildings, that have been built in the world. And this process, as you can see here by the data in the under the pictures, is it takes a long time to build these buildings. The Empire State Building being built in about a year, and with 7 million man hours. The buildings even today are taking even longer to build if they are taller. So think about this: 22 million man hours to build anything in the world. There's probably room for improvement. And so thinking about that, in terms of our productivity for our buildings, it's not necessarily that that there's any specific piece of this puzzle that isn't trying to do a good job. I think goodness knows our workforce is working as hard as they possibly can. And this is becoming more and more evident, obviously, with COVID and everything like that. But it's not really something that we can just will people to work faster on. It's a completely new mindset that we need to think about. Our construction practices in general, the way that things are put together piece by little piece, is just maybe not the most efficient way to build buildings, or to retrofit them. And so thinking about that, thinking about not only thinking about that bigger picture goal of decarbonizing the building stock by 2050. It's not just what we need to do to retrofit what's there, but thinking about the scale that we need in order to meet the demand of the growing population that we have in our country. Looking at this middle section here, the global building stock is expected to more than double in area by 2060. So that's like building an entire New York City every 35 days for 35 years. It's a problem that we need to start thinking about these solutions in a different way, because what we're doing right now just won't get us there. And in addition, another challenge that we're dealing with is just the amount of retrofits that we see today, especially ones that even consider energy efficiency, are just not at the scale that they need to be. One of the reasons for that could be that people just don't think about it. Another reason could be cost. Another reason could be that we're not necessarily thinking about this part of our industry in the same way that consumers and other building owners are. In terms of a lot of the things that that they think about are how can value be added to their building in a way that benefits them directly. And so just having that reimagination of how can we really think about this in a new way is really what the Advanced Building Construction Initiative is all about. So in thinking about what this might look like, there are to again mention the Netherlands. They are I would say ahead of us in this thought process. Similarly, they're thinking about that speed and scale mechanism. How can we address the building stock needs for our country? And in some cases, we're actually starting to see some of that pull into the US in terms of modular construction, panelized construction, things like that, where the on-site time is diminished greatly because it has been prefabricated in a manufacturing facility where people can specialize in the same way that happened with cars, in one job that they can do over and over again in the same environment. That really can help increase productivity. Um, the challenge that we're facing right now is that even though the US is starting to think about this, we are having to import a number of these modular pieces from other countries that are ahead of us. And so really what we're trying to think of now is not only how can we kind of catch up with what some of the other countries are doing, but how can we think even more in a way that is going to benefit our building stock in the US, which a lot of that, again, thinking about those older, that older construction and retrofits. So the Advanced Building Construction Initiative is thinking about this in kind of a holistic way. Not only are we thinking about what are the solutions, what are the technical things that are going to help us get to this point, but also how can we pull in the demand side and that market transformation. And the way that we're connecting those dots is really through what we're calling the ABC Collaborative, which is a kind of market-facing group that is helping to aggregate the demand for this type of product. This kind of thinking, you know, in terms of how can we better approach our strategy here as a nation. And so the four key objectives that kind of frame everything for the Advanced Building Construction Initiative really are these four objectives. We're looking for superior energy performance and low embodied carbon. We're looking for fast construction and renovation, and making that affordable to developers and consumers. And then again, none of this really it matters unless it's appealing or there's some type of added value that we can provide to the folks that would be buying the the retrofit or the new construction buildings. That could be developers, consumers, things like that. There's other parts of this though that could potentially benefit um, other industries as well. And so we're trying to think about that as well. How can we pull in, for example, a resilience angle, making sure that the insurance companies are well aware of that added value, and how can we pull in, you know, utilities and thinking about, well, if we're reimagining kind of how we're thinking about our building stock, how, you know, can we also make sure that we're benefiting utilities in terms of when they have a clean electrical grid, how can we best help enable that in terms of ability to shift load and things like that. So so these are all some of the guiding principles. Kind of just again to reiterate some of that, I'll just touch on a few other points. You know, that offsite construction and manufacturing is really an important part of this initiative. It in thinking about bringing again that component of industrialization to our own country, making sure that our workforce has that option to participate. Um, and and talking about the workforce, not only are we thinking about that in terms of an offsite sort of factory situation, but also in our solutions that we're thinking about that can make retrofits and new construction better, faster, and less expensive. How can we help make that job easier for the workforce that's on site? Because obviously there's going to be work that needs to be done on site as well. We want to make those jobs safer. We want to make them, you know, make it so that it's a desirable job for people to have, because it's in integrating you know, new technologies and things like that that make their work easier to complete. And so that's kind of all part of the thinking. We're really looking across all points in the supply chain and thinking about that streamlined delivery of these solutions. How can we make sure that whatever is kind of thought about in this space is not just thought about from kind of the early stage R&D standpoint, but it's tying in all of those stakeholders along the way in the supply chain. Some of the things we're thinking about include how are we going to quickly collect data about existing buildings? What kinds of materials are we going to be using that are low carbon? How can the components that are designed be quickly put together, snapped together on site or in the factory? How can manufacturing be more streamlined in and of itself? And then how can we make that installation process as quick as possible and again as safe as possible for workers too? As part of this, I mentioned the ABC Collaborative is an organization that is working to um, aggregate the demand side. And so if you think about this organization, they're organizing that supply and delivery chain. They're trying to understand really the market challenges and barriers and connect those dots with the type of solutions that might be coming down the line from the kind of R&D stakeholders. They're thinking about things like financing, how to remove barriers just from the perspective of, again, builders and other stakeholders like that would be purchasing or remodeling contractor business models, things like that. So all of those kinds of things are kind of coming up as as under the ABC Collaborative group. In addition to the things that I just mentioned, you know, we're also just, again, this is trying to connect the dots for the different components of the ABC initiative. So thinking about that R&D, the supply, the demand, and the market enablers. Really, again, the ABC Collaborative tying that all together. This is really an initiative that has the potential to drive significant long-term change. That's really the goal. You know, again, in rethinking how can we revamp our minds about our buildings and how we approach them. This is really in support. It is one piece of the supportive puzzle for our new administration's goals. And all, again, thinking about keeping our manufacturing jobs in our country, making those jobs desirable and safe, and um, really working on our leadership in this area. So to learn more about the initiative, you can go to these websites. I'll also say that I'm helping to develop the roadmap for this initiative, which should be coming out for public review in September. So if you'd like to be involved in reviewing that, this is all about how are we going to get there, the how. Feel free to email abc@ee.doe.gov, and I look forward to involving whoever would like to be involved in these conversations. Thank you.
You all see me okay? Okay. All right, moving on. Thank you, Sharon, for the enlightening presentation on streamlined approach to the expanding building segment. We're going to move on to our third presenter. This is Cecilia Hahn-Springer talking to us about green public procurement and Buy Clean policy programs around the world. All right, a little about Cecilia. She is the senior researcher with the Global China Initiative at the Global Development Policy Center. Her interdisciplinary research focuses on industrial decarbonization and the environmental impacts of overseas infrastructure investment. Previously, she was a doctoral fellow at the Harvard Kennedy School and an affiliate at the Lawrence Berkeley National Laboratory. She earned a MS and PhD from the Energy Resource Group at the University of California, Berkeley, and a BS in Environmental Science from Brown University. Without further ado, Cecilia, it's your turn.
Hello, everybody. Are my slides showing all right? Okay, stop me if they aren't. Thank you, everybody. It's great to be here. Today, I'm going to talk about green public procurement and Buy Clean policies and programs around the world. And I think a lot of the content of this presentation hopefully complements what we've heard earlier, and especially from Dinah about some of the specifics of Buy Clean. But I'm going to take a little bit more of a global sort of bird's eye view. And so just to kick it off, green public procurement here, I really want to point out in the definition, I know we've discussed it already on this panel, but green public procurement is a process through which public authorities, governments, regulators seek to procure goods, services, and works with a reduced environmental impact. And I just want to point out that this is compared to goods, services, and works that would otherwise have been procured. So this relative impact of green public procurement is what makes it a real powerful policy tool. And it has been a policy tool for several decades, although in recent years, green public procurement's potential has been increasingly recognized internationally. For example, the UN highlighted the importance of public procurement in its Sustainable Development Goals, the SDGs, specifically Goal 12 on sustainable consumption and production. And sort of green public procurement by another name has also been promulgated through the Buy Clean policies that were discussed earlier. So setting standards such as carbon intensity standards for the procurement of public goods. And so this is really important and can be an incredibly powerful policy, even though I would say that it's often sort of understudied. But because public procurement at the national level accounts for an average of 12% of GDP in developed countries and up to 30% in many developing countries, as well as that the products that governments tend to procure tend to be very carbon intensive, as well as large scale. So green public procurement policies could have a substantial impact on reducing emissions associated with construction. And so for this research, we conducted a standardized review of green public procurement programs in 22 different countries, collecting standardized information for each of those countries' programs, such as the laws and regulations associated with their GPP policies, the government agencies in charge, specific goals and targets set by the programs, as well as their scope and coverage, the different environmental concerns that they were targeted at, how these programs were monitored, if at all, and if they had any sort of tools or programs to aid the procurement, the green public procurement process. And this sort of standardized format allowed us to sort of easily compare the programs to one another. And then from within those 22 countries, we selected 4 best practice case studies, one from each region, among North America, Asia, Europe, and Oceania. And so I'm just going to go through those 4 case studies, and happy to share more about the full 22 if others are interested. But first, from Asia, we found that Japan was actually a very early adopter of green public procurement policies and remains a leader. And in fact, it started in the late 1980s with an environmental labeling program called EcoMark. And currently there are 2 laws that require government agencies to apply green purchasing criteria for procurement, as well as to follow green contracting requirements. And the latter is oriented more towards GHG emissions reductions. And Japan's Ministry of the Environment is the main government agency managing green public procurement there. It develops the basic policy outlines and designs evaluation criteria, as well as the items that are eligible for green procurement. And these cover a wide range of environmental concerns, from air pollution to climate change and greenhouse gas emissions, as well as biodiversity loss and energy conservation. And so, again, it's also a large scope of items, products, and services covered. And the annual monitoring and reporting process has to happen for the Ministry of the Environment. And so all of the central government ministries in Japan, as well as 47 prefectural governments and all cities, are subject to these policies. And so it's mandatory at the central government level, but voluntary for local governments and administrative agencies. And interestingly, Japan has the highest percentage, around 70% of agencies that are implementing green public procurement policies compared to other countries. And there has been reported successes, estimating that the program has reduced quite a lot, 210,000 tons of CO2 emissions equivalents. And this work is supported by NGOs like the Green Purchasing Network, which provides things like training and information for those seeking to implement GPP policies. Moving on to North America, I'm going to focus on the US, which again was discussed by Dinah earlier, but a little bit more background. Green public procurement began in the US with recycling programs under the Clinton administration. The Bush administration moved it more towards energy conservation, and then under Obama, procurement policies were more oriented towards greenhouse gas emissions reductions. And again, this can be a very powerful policy tool because in the US, 55% of greenhouse gas emissions from public institutions are a result of government purchased goods and products. And so we can see that the focus of these policies has changed over time, but the formulation and implementation of the policies is quite decentralized and spread across many agencies, with the OMB, Office of Management and Budget, largely playing a coordinating role, but EPA, the General Services Administration, and so on, also taking part in these programs. The scope continues to be expanded. So currently they cover things like electricity, constructions, operations, office supplies, and so on. But the Clean Future Act that Dinah mentioned was proposed by the House Democrats in March of this year. The bill is currently under review in the House, and it proposes to reduce embodied emissions that are more from carbon-intensive materials like aluminum and steel and so on, and would establish a federal Buy Clean program, as well as a national environment product declaration database. So there is an annual reporting process to OMB, as well as semi-annual reports on green procurement to the Congress. There are several tools that aid GPP in the US, such as the US Department of Energy's Green Buy program, which provides sort of awards and recognition for DOE sites around the country that go beyond minimum compliance in terms of purchasing certain products. And it also provides information for contract language and reviewing and engaging with green suppliers. So it's meant to be an incentive program. Additionally, as Dinah mentioned, there are also buy clean policies proliferating at the state level in California, as well as Washington, Minnesota, Colorado, and a bill has been introduced in Oregon. And then in Oceania, we identified Australia as being a outstanding example of having best practice green public procurement. The Australian and New Zealand government framework for sustainable procurement was adopted in 2007 and was intended to guide the national, state, and territorial governments of Australia and the governments of New Zealand in integrating sustainability principles into their procurement decisions. And Australia itself has several national guidelines that have been updated throughout the years to cover different scopes and different environmental metrics. And so typically GPP implementation and formulation is at the state level, and the product scope includes construction and building supplies and services. Again, Australia also has a number of tools to aid green public procurement, such as the Eco-Buy program, which includes a database of environmental products called Eco-Find. It also provides training and events, consultancy services, organization of trade fairs, as well as a sustainable procurement assessment tool to measure sustainable procurement performance. And then finally, I'll talk a little bit more about the Netherlands, which I know Dinah mentioned earlier, but here again, a bit more background. So in 2005, the Netherlands introduced its first set of comprehensive green public procurement criteria and targets for contracting authorities that are involved in procurement. And then this was followed by the procurement law of 2012 that established a socially responsible procurement policy and associated criteria. So again, the Netherlands has been recognized as a frontrunner in green public procurement, having achieved its own goals that it set for itself. So in 2005, the target was set for a 100% green public procurement by 2010 for central government. And this was achieved in both 2010 and 2015 benchmarking assessments with slightly different success rates for the covered provinces and municipalities. And interestingly, the policy also applies to district water boards. And this may also be in part attributed to the many tools that are provided. So Dinah talked about the DuboCalc lifecycle assessment software, and there's also a CO2 performance ladder scheme, which is in use by the Dutch government entities and private companies for procurement of construction works and materials. And it's voluntary, but it certifies suppliers at different levels with incentives to continually improve and move up the so-called ladder. And so what we learned from looking across these different countries and case studies, we looked into barriers in specific countries and then kind of generalized. So a lot of the barriers that green public procurement face as a policy often range from a lack of products on the market that can meet the desired environmental criteria set by policymakers, as well as general lack of information about the benefits and importance of green public procurement, both from a financial and environmental perspective, as well as the lack of human or financial resources, especially in countries facing budget constraints to implement GPP programs, as well as barriers that can hopefully be corrected through knowledge sharing of best practices, such as through our research about how to establish what products and services are eligible for green procurement. And some of the policy recommendations from our report, our foremost recommendation is that, using the power of public procurement for sustainability should be adopted by countries that don't currently have a GPP program, but that do have commitments to environmental sustainability. This is one relatively low-hanging fruit type policy that should be adopted more widely. And countries that already have green public procurement programs should learn from and apply international best practices to improve their programs. And we found that performance and compliance for green public procurement tends to be most widespread at the national level, but there should also be subnational adoption of these policies, and we should think beyond the unit of the nation state. And there are also large institutions with major purchasing power that can adopt green public procurement policies, like the UN or the World Bank, for example. And then, given the pressing nature of the climate change crisis, we also recommend that countries more explicitly address energy efficiency and embodied greenhouse gas emissions reductions in their GPP criteria, especially for these carbon-intensive materials like steel, cement, concrete, and so on that have a significant greenhouse gas footprint. And then finally, as we could see from the best practice countries, oftentimes having widely available easy-to-use tools can help local agencies and central government agencies implement GPP programs. And this includes tools like eco-labels, life cycle assessment software, and data that facilitates regular monitoring and reporting. And so just to sum up, we found that there is a wide range of countries and institutions that practice GPP, and some of the best practice countries cover a wide range of products, a wide range of environmental concerns, and also provide extensive tools to support GPP design and implementation. Many of these programs have demonstrated success through having regular monitoring and reporting. And so those monitoring and reporting processes are very crucial for continuing to promote GPP around the world. And then finally, because of the significant GHG emissions associated with products and services often procured by such agencies, public entities should use their purchasing power to enable a green transition. So I'll stop there. Thank you so much.
Thank you, Cecilia, for providing a view of best practices on GPP from around the world. It's really encouraging to see the progress and success being made in different countries and across all these governments. Let's move on to our fourth and final presenter, Elizabeth, aka Betsy Dutroux, speaking to us about the potential to decarbonize the US manufacturing sector by 2050. Betsy leads the US Environmental Protection Agency's Energy Star Industrial Partnership, a voluntary program that helps manufacturers improve energy efficiency. Her design for engaging industry in Energy Star and securing high-level attention for corporate energy programs to succeed has enabled hundreds of companies to build productive energy management programs. Through her efforts, major industries are actively engaged in energy management with Energy Star and can benchmark their plant's energy performance nationally and identify opportunities for energy improvements. Betsy has a degree in chemistry and is a certified energy manager. Without further ado, it's your turn to speak, Betsy.
Thank you so much. So what I'm going to talk about today is an evaluation that we have conducted of the potential for deep decarbonization in the industrial sector by 2050. I should be clear that this is a study of the potential for CO2 reductions from the US manufacturing sectors by the year 2050. And I also want to note that we are aware that carbon dioxide is also a process byproduct in many of the heavy industrial sectors. We did not include this part of in our study, but we did look at carbon dioxide emissions reductions from process emissions in the cement sector, since they are large. Also want to cite my co-authors with whom this work would not have been possible. First, Dr. Gail Boyd, who is Associate Research Professor in the Social Science Research Institute and Department of Economics at Duke University. Second, Ernst Worrell, a Professor of Energy, Resources, and Technological Change in the Copernicus Institute at Utrecht University. And finally, Josh Smith, who is a Director of Public Policy at ICF. Without them, this work would not have been possible. So why do we consider the industrial sector? We're all working on this, and generally we all know this, but pictures always help to remind us. The industrial sector, when you attribute all electrical emissions and across the use that these sectors have, and you looked at the major sectors of the economy, industry has about a 29% share of greenhouse gas emissions. And when we think about this, we know that industry, by the way industry is defined, can include manufacturing, agriculture, mining, and construction. So what is the share that manufacturing has is the question. Well, we know that's about 77% of greenhouse gas emissions. And of these, about 85% of them are carbon dioxide related. So that is what we're talking about, and we're looking at the industrial sector. So why this evaluation? Well, many have studied the manufacturing sector's opportunities to reduce their carbon dioxide emissions. Some of the studies that we've looked at explore specific technologies. Others, on the other hand, look at specific sectors and what you can do in them. They all show that there is potential to reduce carbon dioxide emissions. We were asked a question by our management, what is the full impact, though, when you consider the opportunities for increased energy efficiency, electrification, renewables, and grid balancing? What do you think the potential reduction could be? So the question that has not been answered across the board is how much decarbonization really is feasible. So we looked at the manufacturing sector. If you're familiar with the North American Industrial Classification System, this would be the sectors 31 through 33, which means that we were looking at everything from certain types of food products to broom manufacturing. And what's in between there is everything that's made in the US, including our heavy industries that we all talk about, like cement and steel and so forth. But they're all there. We looked at the opportunities for energy-related emission reductions, and we looked across dozens and dozens of studies that were published that we felt were reputably reviewed and were out there. And we looked to see how much opportunity the manufacturing sector had in mainly 4 areas: energy efficiency, electrification, renewables, and grid balancing. We also looked, because it's important, at some specific technologies such as combined heat and power, carbon capture, use and storage, the circular economy, which is becoming very important. Also, we'll refer to that going forward as material efficiency. And we looked at hydrogen. But we had to start somewhere. So the question is, where do you start, since the sector is so huge? Manufacturing is everything we think of, and it's diverse. So we adopted the United States Energy Information Administration's annual energy outlook for 2019 for its estimates of manufacturing's emissions. That's where our baseline started. The sectors that we looked at included iron and steel, cement, chemicals, pulp and paper, refining, oil refining or petroleum refining, aluminum and glass, and light industry. Light industry is everything else, and there are some energy intensives within that sector or that definition we have. But there's also a lot of very non-intensive industries in there. And so there's a large number of smaller industries included. I'd like to talk a little bit about specific sectors. The first one we'll look at is pulp and paper. And this slide and the next one are going to show how the assessment went together and some of the information pieces that went into forming our opinions. In the area of energy efficiency, for pulp and paper, based on the studies reviewed, we believe there's a 40% efficiency improvement possible in fuel demand by 2050 and a 30% electricity savings potential. This would cover increased heat recovery, which we think is there's more that could be done, shifting to best available technology like the latest in all of the motors, pumps, fans, and even increased combined heat and power. In the case of material efficiency, we don't foresee an extensive reduction for the products in this industry because demand patterns are likely to change. As we embrace a circular economy, there will be a need for more paper products, more than likely, as other types of manufactured products become less demanded. We also think that there's a potential for more recycled fiber use, and that there's room to grow in that regard. So this will reduce fuel demand by a good amount in the sector. We believe that renewable energy can grow and that there could be better harvesting of residues, growth in biomass CHP. There's potential for geothermal. All of these might be things that the industry can take on in the future. Studies are looking at them and they're showing potential. There may be new process design. There's some work on pulping, and there's some water-free paper making research underway. And in the area of electrification, there is potential for infrared or even microwave technology for drying that is under development. A second industry that I'll give as an example here is iron and steel. The last 3 days, we've heard a lot about iron and steel, and everyone's looking at them, but we looked at them as well. Energy efficiency improvement can be made further in this sector. And again, we realize there are two types of plants we're talking about that are in existence currently. There are some new types of plants coming online, which will offer great opportunity. Material efficiency is important for this sector, as increased recycling is going to be important. And new products may demand less material, so there will be impacts for the sector that way. The two technologies or the two processes that are listed here, both will reduce carbon emissions, and each of them will be very important for this industry moving forward. And we've already seen some adoption already in certain cases, particularly with direct reduced iron. So the analysis gives a picture of industry, and we thought the old dashboard might be helpful with the red, yellow, and green being high potential, yellow being medium, and red being low. In the case of this table, across the top, you'll see the industries listed, and down the side, you'll see the deep decarbonization potential for the industry opportunity. What we see for energy efficiency is that most sectors, and even as we have listed chemicals at medium, we believe there's still good potential for energy efficiency across all of these sectors. Material efficiency will be most important for sectors like pulp and paper and steel. We believe that renewables has great opportunity in light industry because the light industry generally uses lower temperature processes that can be more supported with renewable energy. Hydrogen and carbon capture and storage, you may be surprised why we've listed these as medium to low. Well, first of all, the earth shots were not available when we did this work, and we felt that there was a huge hurdle that each of these has to overcome, and we still think that's the case. But pricing and availability, as it's changing, will change perhaps our estimates of the potential in all of the sectors. Some already use hydrogen and can use more. Others may be able to pick some up, and some it may not make sense at all ever to use. So that's how we created our assessment. 86 is our special number here. That's our percent reduction that we estimate is feasible from US manufacturing by the year 2050. And it's through the key activities of energy efficiency, material efficiency, industry-specific technologies, and power grid synergies. Let me just describe carefully what, again, we mean by this. By energy efficiency, I'm going to assume everyone understands. But we'll talk about material efficiency, structural changes in manufacturing that include product recycling and reuse, material substitution, and demand reduction. That's what we meant by material efficiency. Industry-specific technologies are things such as carbon capture and storage and utilization, hydrogen, and non-power generation renewables. And finally, power grid synergies include a shifting to a zero-carbon electric grid that is enabled by procurement practices and load balancing combined with beneficial electrification of fuel-using processes. Now I'm going to talk a little bit about how we can visually think about this. So I mentioned that we needed a baseline year. So the annual energy outlook baseline year for 2019 was 2018. Industry's emissions in that year were estimated by EIA to be 1,141 million metric tons of carbon dioxide. The 2050 reference case that EIA has created shows industry growing to 1,282 units. Our estimate of what direct actions industry can take will have, or the impact that these direct actions will have, shows industry dropping to 649 units And then the grid interaction that I mentioned earlier can drop industry down to 184. So let's look at this a little more detailed now. This chart shows the same black and gray lines that you've seen, or bars. Here you see the original estimate of EIA at 1282. But on top of that, there's a blue chunk of 429 units. That's because the Energy Information Administration, in their estimate for 2050, includes a built-in amount of energy efficiency that is happening today through policies and programs, like the Energy Star program, and like some of the policies we all know about for efficiency. These programs are not estimated to go away in the 2050 estimate. So they're very important to what we have to keep going for industry not to grow further. If these programs were not in place, we estimate that industry's emissions would be up close to 1,700. So that blue bar is very important. Now we go to the second estimate, our first estimate rather, of emission reductions. We estimate we can get down to about 649 units. This reduction that we've already counted is there. You can see it in the dark blue. But beyond that, we think another 91 units is possible for additional energy efficiency not already accounted for in EIA's estimates. We included the petroleum sector in our analysis because it's very important for carbon emissions from the manufacturing sector. But we do, in our estimates, believe that the petroleum industry will decline. And so through a material efficiencies perspective, we believe refineries emissions will decline, and we've estimated that in the orange bar. Lighter orange is material efficiency for the rest of industry, which is all of the things you can think of. Better use of recycled products, maybe better use of plastics and recycling of plastics. On top of that, we have a smaller slice for renewables, where they can apply for industries that can use them. Hydrogen and carbon capture, as I said, are later technologies we think that will be important, not immediately. Now, finally, we come to the fourth bar, and we see that we can drop to 184 units. What is this representing? It includes the difference between the third and the fourth bar, and part of this is due to the grid decarbonizing. We're all working for a decarbonized grid. We're hoping for that. If that happens, the energy or the electricity that industry purchases from the grid will be decarbonized. So we count on about 270 units of energy of CO2 savings from that decarbonization of the grid. And finally, among the industrial sector, there are parts of it in the manufacturing that can move to electrification when the grid is green. And that is a large part through light industry. There are several insights that this analysis has brought to us, and I think you probably have arrived there as well through some of your work. But the first is that energy efficiency enables greater reductions. It really has great potential remaining, and it is a key action for the early years, now and beyond. It's going to help pay for some of these more expensive opportunities. So it buys down the price, so to speak. It's also low in cost relative to other options that are out there. It is prevalent in both light and heavy industry. And some sectors, if they implement technologies and electrify, so perhaps the heat pump in the case of this example, might have double the benefit from energy efficiency. Additional insights surround material efficiency. This is going to mean a lot of change and acceptance by the consumer. This is big change. And as we start thinking about how we make things and how carbon dioxide needs to be managed properly, and we need to look bigger picture, there's going to be big changes that will have to happen for consumer demand to help mitigate some of the CO2 reductions. So there needs to be work in that area. A decarbonized grid is going to be very important to enabling industry to electrify, and green hydrogen is our preference for fueling the hydrogen. There are a lot of opportunities out there and a lot of colors, as we've all discussed the last 3 days. Electrification is something that will be great for low temperature processes where industry relies about half on electric, and the motors and such are already there. There are lower temperature processes that could have various warming processes through electrical opportunities. So there's more opportunity for light industry to electrify. Carbon capture and storage is probably going to be the end result for many of the industries that have fewer decarbonization opportunities. But if we can work with these industries to get them to implement all of these other opportunities, then the amount that may have to be decarbonized through carbon capture and storage or use could be less. And then hydrogen will have a role in certain industries. So the conclusions of our work is industry can reduce CO2 emissions significantly. 86% is our estimate of feasible reduction. We can't rely on one approach. We have to try them all, and they all have to be tried now, starting now, or things are going to just get more expensive in the future. How many times haven't we all wished we had purchased something several years ago instead of waiting till now? And then following manufacturers' natural capital stock investment cycle is very important, because what they're putting in place now with new equipment is going to be around for a long time. And so I look forward to seeing your questions.
Hi, everybody. We're back. Thank you for that awesome presentation. Very comprehensive, and I haven't seen anything like that before. So now if we can bring all of the other speakers onto the stage, we can go through the question and answer session. All right. Well done, everybody. Great panel. All right, so we've got a few questions, and we've got about 10 more minutes, so let's go right into it. So first question for Dinah. How did you calculate the carbon intensities for cement? What data source did you use? And is it really part of just a life cycle emission or just a cement plant?
Yeah, sure. Thank you for the question. So in terms of data sources, we looked at reported emissions data to regulatory agencies such as the California Air and Resources Board. We were also looking at production data from facilities, as well as production and import data from the USGS annual reports. So for example, one of the things that USGS tells is that the percentage of imported cement towards consumption. And then in terms of scope of emissions counted, the scope included in the carbon intensity that we looked at included direct emissions, direct process emissions, which a couple of people have mentioned that that's a significant part of cement. So that's definitely something worth including, as well as fuel consumption and electricity, but not the entire life cycle. Or another way of saying that is scopes 1 and 2, but not 3.
Great. Thank you for that. The next question is for Sharon. Are there ways we can use modular construction to build local community employment opportunities rather than centralize the construction?
Yes, I definitely think so. And, you know, there definitely needs to be, as part of this thought process for modernizing our construction industry, you know, the whole supply chain, including where the factories are, definitely matters. In addition to needing a suite of factories around the country and not just a few, we would also need a large workforce to work actually on site as well, just because there are still things we still need to actually, get the buildings retrofit and constructed where they are as well. So I think there's definitely an opportunity for sure for to be more localized.
Great. Now moving on to Cecilia, couple of questions. Are there efforts to harmonize labeling of green across countries? And what are the most expensive parts of implementing a GPP?
Yeah, so I think that in terms of harmonizing criteria, it's really interesting to look at the case of Europe. So I know I mentioned the Netherlands as a case study, but Europe has also GPP policies at the EU level through the European Commission. And so given that those policies are voluntary for member states, there was a lot of proliferation of different types of criteria at the national level. So harmonization is really important, especially for creating a market for greener products. And so in 2008, the European Commission started a process to harmonize those criteria, and they they chose high priority products for standardization. And so there are now 19 product and service groups, including roads, office building design, and so on, with more harmonized criteria that were chosen through this multi-criteria analysis process. And so, yeah, so that's a very important ongoing issue and should be done, at a more global level, certainly. And then for the second question on the most expensive part of implementing GPP policies, I mean, I mentioned that there's issues with human resources, but policies don't drop out of the sky. And so, one of the things that we learned from barriers to green public procurement in China, which has typically been, often quite successful in implementing top-down environmental policies, is really this problem of finding an approach to program management. And so, what would be the designated agency to do this? Are there personnel there with the appropriate experience and knowledge? And then once you do that, how, who has the authority to really actually implement the program and provide the tools to support that program? And so, there isn't an assessment of the cost of different parts of any GPP policy that I've found in this review, but I would think that, again, the human resources that it takes to bring together such a program can be a major barrier.
Thank you. Now moving to Betsy, what sort of policies do you think are needed to promote adoption of decarbonization technology to replace equipment up for retirement?
It's a good question. And it's a difficult answer because industry is, depending upon who you talk to in industry, there are different replies. Some people hate tax credits because they feel it picks winners and they want a natural market. And you can probably find those types of folks around. And yet at the same time, there are probably companies that could use help. So any type of policy instrument in that regard would help with depreciation. These plants that are out there, some of them are very, very old. Some of them have parts of them rebuilt. So we really, my goal or my vision of industry is a modernized industry that is not polluting, that is doing what it needs to do. And we're all happy with what they have. They have jobs. That's what I envision the best would be for everyone. So whatever gets us to that point. I will say there's one angle that gets to smaller industry and the difficulties with that. They're hard to reach. Smaller companies are hard to reach. So there needs to be a way to reach them not only with new ideas and help and assistance, but also getting information out on things that do help them to modernize if there are tax-like opportunities.
Great point. Great point. Moving back to Sharon, How do you define key elements such as superior energy performance and low embodied carbon to ensure a level playing field? Example, are these done through standards and plus common MV and R principles?
So I'm not sure I understand all parts of this question, but I'll try to answer to the best of my ability. But in terms of defining, I guess, the specific goals or target metrics around energy performance and low embodied carbon, we have more information about at least the energy performance side in the roadmap to come. It's how we're defining it is really about, we're trying to think about how the intersection of cost and energy efficiency or carbon reduction through from an operational carbon standpoint. And so thinking about not over improving and obviously not under improving. And then from the embodied carbon side, in terms of how we're defining those metrics, we are just starting to think about that, but I'm loving how this panel is getting very specific about some of those metrics. And so I'm definitely going to potentially be calling folks to see if there's any input on that side. So that's definitely under development.
Understood. Now back to you, Betsy. Was CHP captured under any of the DDM strategy? And did this study account for any increase in new manufacturing?
So CHP was looked at across several sectors. So yes. Did we look at new manufacturing? We looked at, as Gail Boyd, my esteemed colleague, has said here, that the AAO reference case was part of the analysis, and that did not include these new industries on the horizon. But he did point out, and I'm reading what he's written here, but the electric vehicles will likely use less steel, so they can contribute to material efficiency. I would also say that new industries, Gail has continually pointed out that the light industrial sector is always growing. It's probably the only part of industry that's always growing. It's still small compared, well, the emissions are smaller, but there are a lot of new industries in there all the time. So they will be very important and they will be part of the solution.
And another question for you, do we need different policies for different sized companies, or is it kind of an overarching set of principles that covers everybody?
So to Neil's question, the word policy is loaded to me because policies can be programs, they can be punitive, they can be positive, and so forth. And I do think there are not any one set of policies that's going to get all of this fixed. So yes, more than likely we do. And I find it very difficult with what we do with industry in our program through Energy Star to reach the smaller companies and some of these more diffuse industries. It's very easy to access less than 100 cement plants. It's very hard to find the metal casters who are all over the place and of all different sizes. So we need different ways of getting to these.
And I think we'll wrap up with this last question, again, for you, Betsy. So you mentioned that consumer demand will be important, but for consumer products that are longer lasting products that could be upgraded or repaired, what's the material efficiency aspect of it, and how do you apply that?
Well, it certainly is under that category of material efficiency. Design for reusability, I believe, is a term. And we certainly have folks around the world that are looking at that. Europe is much further advanced and people think differently about what they throw away. So we do need that to grow, and I think it does fit in there.
Fantastic. Well, we're at the top of the hour, and I want to thank the presenters today. It's been really enlightening, and I've definitely learned more than when I came into the panel moderation with, so I appreciate that. I want to remind the audience that we have end of the day wrap-up session where you will get to meet some of the speakers and have more of a informal discussion. So please join us, and we'll wrap up here. Thank you again, and have a wonderful wrap-up to the conference.
Thank you.